Hi guys, this is Gary from Virtual Pilot. Today we're going to take a look at the Sentinel antenna tracker for iNav, Betaflight, KISS and MWOSD users. We're going to start with a high-level overview. We'll take a look at how it works, key features, look at the unit itself, the kit, and finally we'll take a look at the GUI configurator and a few clips of the unit in operation. So this is a low-cost DIY tracking kit that's suitable for any of the standard flight controllers out there that use the embedded MAX 7456 style OSD chips. So that's your typical MATEX Omnibus iFlight style flight controllers. It's also supported by MWOSD, so that means anyone running a Minim style OSD hardware. You talk about your PX4, Ardu Pilot, Ardu Copter, KISS, etc. Or even for the guys that are just using GPS only through a Minim OSD, then you guys are covered by this unit. Needs no additional hardware on the aircraft. Yes, that's right. No additional hardware is required. That means that for you guys that run large fleets like myself, then you don't have the additional expense of a module in each unit. Similarly, on the ground side, your RC transmitter does not use Bluetooth or Wi-Fi or anything to connect to the tracker and pass through any of the tracking information. So the benefits of that are basically any RC transmitter supported. You're not limited in your choice. It also means you do not have any reliability issues with other 2.4 gig users in the area. So anyone running say a 2.4 high-powered VTX or even normal 2.4 RC control, they're not going to affect you at all. I'll run through some of the key features listed directly in the manual. So I'll read these off the screen now. So first one, it supports iNav and Betaflight, running on the standard MAX 7456 OSD-based flight controllers. Also supports Minim OSD users. So that's your Ardu Pilot, Ardu Copter, KISS, and even some of the older systems such as MultiWii, Spaceflight, even DJI NASA is supported. Tracker has a built-in GUI configuring for configuring. This is supported by Wi-Fi on any web browser, so iPhone, Android, PC. Enables adjustment of the servos for faster response or smoother response. And there's also an emulator in there as well for setting up and testing the unit. Supports OTA updates, so that means no cables required for any firmware updates or any adjustments. You can do it all over the air. It has a ground station battery voltage display, which is available in both the GUI and also the OLED module on the unit if you fit one of those, which is included with the kit. Also comes with a configurable audio alarms for low battery voltage and also for low tracking RSSI. On the OLED display, there's also some other eye candy, such as your pan, tilt angles, that sort of thing. Comes with 2 video and 1 audio output. They're provided by a single RCA for the video and also a Fatshark compatible 4-pole output as well. Both can be used at the same time, so they're actually both got separate video driver chips on those. Supports NTSC and PAL analog video, so pretty much everything in the market today. Also runs from 3.4S LiPos. Yeah, that's probably the key features. Okay, we'll take a look at the actual physical unit. So this is one that I've already printed. This is a kind of I guess, the base standard units as such. On here, you can see your OLED display, which will have your voltage, RSSI, sorry, your tracking RSI, SSI on there. A couple of power connectors. One is for the unit itself, and the other one is ganged to that, so it can be used as an output to fit an external monitor on there. Single RCA, which provides one video output. There's also a Fat Shark compatible 4-pole connector there. That's got video and audio. They're both independent of each other with separate driver ICs, so you can use both at the same time. You have a few LEDs on there to show power on, that the unit has tracking signal captured, I think Wi-Fi enabled, and I can't remember what the other one's for. On the underside, I'll show you that there. That's a standard-ish QR adapter. I say ish because the standards seem to vary a little bit, but this fits the Hammer Star model, which is very, very good value and seems to be one of the most popular ones out there. And it does actually fit all bar one of my tripods that I have today. In terms of the sort of pan tilt mechanism, you have a mounting plate there, and I think it's 80mm between the holes on there. So you've got quite a lot of options around that. You can even drill your own in there as well if you want. It will go through vertical positioning right the way through to horizontal and down to about minus 27 degrees, I think, if you fly below the I guess the horizontal line as such. The pan action, it's a full 360 degrees. It uses a standard servo, so it's not a continuous rotation. As it rotates down to the final position, if your plane goes, or aircraft, whatever it is, goes past that, it will very quickly move around to the other side at full speed. Takes about a quarter of a second or something like that. It doesn't. It equates to, in your video signal, a little glitch as it does that. But what you tend to do is you adjust your tracking to fly predominantly in the position you're going to fly in. So the reality is, some flights you won't even cross that line. The servos are rated at 10 kilograms, so that will easily support a 1 kilogram load of a receiver and antenna fitted on the plate. Fit it as close to the plate as you can, because that reduces the current draw and the strain on the servo. Lots of options you can do with if you're into your DIY 3D printing, and I'll show you another unit now. I'm going off the screen, yeah? That's better. Okay, so this is another unit I use. This is actually the main one I tend to fly with. So on this one, I've fitted a 4-inch LCD screen, which is permanently connected to one of the video outputs, and it uses the supply, the spare supply. There's also a battery panel on there as well, again fitted in there. I've got a little switch unit on there. All this is available as STLs, and the source code is available as well if you want to run up Google SketchUp and make some changes yourself. It's very, very easy print. My printer is, I think, 7 years old, very old, and probably about the worst you can possibly have these days, and it prints it's absolutely fine, even some of the complex stuff like the gears. There's also STLs and source files for a Fat Shark compatible sort of mounting unit. So just 4 screws, or in my case 4 cable ties to put this on there, and it's an EA Sheen Fat Shark Diversity RX, so very cheap little unit, I don't know, $25, whatever they cost. Makes for a very, very small, neat solution as part of the sort of overall tracker. So just put it on your tripod and off you go. Do a quick rundown of the GUI configurator. So the unit has a fully embedded GUI. You do everything via a web browser. Uh, and the unit acts very much like a router at home. So you connect to it over your normal Wi-Fi type connection. You put in the IP address of the unit, and then you can access this GUI and change the settings as you particularly desire. So if we go to the main screen now, you'll see in here the configurable servo settings. So you can adjust the endpoints of the servo and the speed at which they operate and the direction as well. Just so you can get your optimal settings for the tracker to make it as accurate as possible. You can change the minimum pitch constraint. So that's if you want it to minimum sort of angle at horizontal, which is the normal, or if you particularly want to fly below your horizontal line, if you say, for instance, on top of a hill, you can adjust it down to go as far as minus 27 degrees elevation. You also have settings for the battery, so you can configure the low voltage alert as a warning if your battery's getting too low, and the appropriate settings that go with that, the number of cells, minimum voltage per cell, that sort of thing. You can also adjust the or enable the loss of signal alarm, which will come on after a few seconds of not receiving any valid telemetry. It's a bit of a warning that something's going wrong. You can also adjust the Wi-Fi mode as well. So if you're a 2.4 video flyer, you don't really want a Wi-Fi access point turned on right by your receiver. So what this can be set to is either disabled or auto-disable. So the moment your flight controller is armed, it will disable the onboard Wi-Fi, and therefore you will not get any interference when you're flying. Which is a pretty useful feature on 2.4, and it removes that issue that you have with the types of trackers that drive the units from their RC transmitter using Bluetooth or a Wi-Fi module. It's a bit of a problem with some of those units. Okay, and you can also access the simulator. You can drive the servos directly. See on the screen here, you can adjust your tilt servo between 0, 90 degrees, vertical, straight up, even down to minus 37 degrees below the horizon as well. And similarly, there's another one where you can adjust the pan servo. So primarily we'd use this for setting up the unit and configuring it, but it's a bit of fun as well. Okay, flashing the unit. So if you want to do an upgrade, this unit operates an OTA process, so no cables required. You do all your firmware upgrades over the air, which is pretty simple and straightforward. You have a signal. Actually, I'll show you the flash settings. So if you want to do an upgrade, click on the select your file, flash, and on the right hand side you'll see the various stages through to the end, and then the system will reboot and you can reconnect to it. Signal chart, we use this a bit in development, so you can save your RSSI signal throughout the flight and download to a CSV file just to see how well it's performing. Probably something you're unlikely to use, but it's a useful feature when we're doing our testing. And I think other options, Wi-Fi, we can change the name of the tracker to be whatever you want within the constraints of what your SIDs are allowed to be. And the authentication mode, you can change it to be a bit more secure if you're particularly a security conscious person. And in the on the actual main screen as well, you can see some other information up here, which about the version of tracker. It will show the angles at which it's tracking. whether you've got telemetry signal, how good it is, whether you've got video, and the ground station voltage as well.